Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle and we know that angle DCB equals to 90 degrees. We know that chord CD equals to 2 units, and we also know that DO equals to 3 units, and actually DO is the radius of the quarter circle, and so we will define it as capital R, the radius of the quarter circle, and also the center of the quarter circle is at point O, and angle DOB, this angle is a right angle, it equals to 90 degrees, and inside the quarter circle we have small circle, and we want to find out the radius of this small circle. So let's define the center of the small circle as point P. Then we will join together points A and P by a straight line. Actually, PA is the radius of the small circle. I will mark it as small r, and we will also join together points P and B by a straight line. And actually AB is tangent to the circle at point A, and AP is the radius, and we have a rule that states that if we have a circle and this is the center of the circle, and we have the radius of the circle. This is the radius, and we have tangent to the circle at this point. So BC is tangent to the circle at point C, and we have this radius. So the tangent to the circle BC is perpendicular to the radius, that is to say this angle is 90 degrees. Okay, so a tangent to the circle is perpendicular to the radius. Okay, the rule that is that a tangent to the circle in this example is BC. BC is tangent to the circle at point C. So a tangent to the circle is perpendicular to the radius. Okay, that is a rule that a tangent to the circle, in this case tangent BC is tangent to the circle at point C, then it will be perpendicular to the radius that also touches the circle at point C. So a tangent is perpendicular to the radius. So according to this rule, AB or BA is tangent to the circle at point A, and AP is the radius. So the tangent AB is perpendicular to the radius AP, that is to say, this angle equals to 90 degrees. And therefore, triangle APB is a right triangle. Okay, you can write down that triangle APB is a right triangle. And if we define angle ABP as theta, then tangent theta equals to AP over AB. Okay, so I will read again the things that I wrote. Actually, triangle APB is a right triangle. This triangle is a right triangle because it has one angle that equals to 90 degrees, and tangent theta equals to AP over AB. And we know that AP equals to the radius of the small circle. That is to say, we substitute AP by small r over AB. And if we multiply this equality by AB, we will get that the radius of the small circle equals to AB times tangent theta. So in order to find out the value of the radius of the small circle, we must find the value of tangent theta and the value of AB. Okay? So we will define, actually, chord CB is tangent to the circle at this point. We will define this point as X. Again, X is the touching point between chord CB or line segment CB and the small circle, or CB is tangent to the small circle at point X, and if we join points P and X together by a straight line, then PX will be equal to the radius of the small circle, because of the fact that line segment PX starts from the center of the circle, that is to say from point P, and ends at point X, that is a point on the circle itself. Therefore PX is the radius of the small circle. And in the next step, we will prove that triangles ABP and triangle PBX are perpendicular to each other. So I will draw them again. We have triangle ABP. That is a right triangle. and also triangle PBX is also a right triangle. So I drew triangle APB and triangle PBX again. We will prove that the green triangle PBX is perpendicular to the white triangle PXP. The green triangle is triangle ABP. We prove that the green triangle APB is perpendicular to the white triangle PXB. Okay, so actually we have AP, side AP in triangle APB equals to side PX in triangle PBX, and both those two sides are equal to the radius of the small circle, therefore they are equal to each other. And we also have PB is a common side, so PB equals to PB, it is a common side. Because PB belongs to the green triangle APB, and PB also belongs to the white triangle PBX. Okay, so PB equals to PB, it is a common side, and also AB equals to BX. AB equals to BX. AB equals to BX, and the reason that AB equals to BX is according to two tangents theorem. Okay, according to two tangents theorem, AB equals to BX. So two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read again two tangents theorem. Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So actually two tangents theorem states that if from external point of a circle, that is to say from point B, that is external point of the small circle, we will draw two tangents to the circle, that is to say tangent AB and tangent BX, then the lengths of those two tangents that exiting from a common external point, that is to say from point B, will be equal. So AB equals to BX. Okay, AB equals to BX according to two tangents theorem. According to two tangents theorem, when you draw two tangents from a common external point of a circle to a circle, then the lengths of those two tangents will be equal to each other. So AB equals to BX. So actually we proved that all the sides of the green triangle are congruent to all the sides of the white triangle. Therefore, those two triangles are congruent to each other according to side rule. Okay, so I write it down. So actually triangle, the green triangle, triangle APB is congruent to triangle PBX according to side rule. Okay, those two triangles, triangle ABP and triangle PBX, congruent to each other according to side rule. Or you can see it in this bigger picture. The green triangle congruent to the white triangle according to side rule. Side rule says that if you prove that all the sides of one triangle congruent to all the sides of another triangle, then those two triangles congruent to each other according to side rule. So from the fact that triangle ABP congruent to triangle PBX, we can conclude that angle ABP of triangle ABP, angle ABP that actually equals to theta, is equal to angle PBX. Okay, angle ABP equals to angle PBX, and we know that according to our definition, angle ABP equals to theta. So we can write here that angle ABP equals to theta, and from this equality we can derive that angle PBX also equal to theta. Okay, angle PBX also equal to theta. So here angle PBX, this angle equals to theta. Okay, or we can see it in the bigger picture. We have angle APB that equals to theta according to our definition. Therefore, angle PBX, this angle, will be also equal to theta according to the rule that corresponding angles in congruent triangles are equal to each other. Again, corresponding angles in congruent triangles are equal to each other. Okay, because of the fact that triangle ABP congruent to triangle PBX, then the corresponding angles must be also equal to each other. That is to say, angle ABP equals to angle PBX equals to theta. So this angle ABP equals to theta, and this angle PBX also equal to theta. Okay. In the next step, we will extend line segment CB and line segment and the radius DO until they intersect each other. Okay, we will extend line segment CB and line segment the radius DO until they intersect each other, and the intersection point will be defined as E. Again, E is the intersection point between DO and BC after we extended them. Okay, and in the next step we will complete the quarter circle to a semicircle. Okay. We completed the quarter circle to a semicircle, and actually angle DCE, this angle, DCE that equals to 90 degrees is the peripheral angle. Again, angle DCE that equals to 90 degrees is the peripheral angle. Why? Because it is inside the quarter circle, therefore it is a peripheral angle. And we have a rule the rule states that any peripheral angle that equals to 90 degrees rests on the diameter of a circle. So I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees rests on the diameter of a circle. So actually we have here peripheral angle DCE that equals to 90 degrees. Therefore, according to the rule that any peripheral angle that equals to 90 degrees rests on the diameter of a circle, peripheral angle DCE that equals to 90 degrees rests on DE, that is the diameter of the circle. So according to this rule, DE is the diameter of the semicircle. And also the diameter of the quarter circle. Okay, so DE is the diameter of the semicircle, so and the diameter of any circle is equals to 2 times the radius of the circle, so DE equals to 2R, 2 capital R, and if DO equals to R, then DE minus DO equals to OE. That is to say, DE that equals to 2R minus DO that equals to R equals to OE. So 2R minus R equals to R. That is to say, OE equals to R. So OE is also the radius of the semicircle, and we know that the radius of the semicircle and the quarter circle equals to 3 units. Okay? And also we know that DE is the diameter of the semicircle. Therefore, because of the fact that DE is the diameter of the semicircle, DE is a straight line. Okay, DE is a straight line. DE is the diameter of the semicircle is a straight line, and we have a rule that states that the sum of the angles on a straight line equals to 180 degrees. The sum of the angles on a straight line equals to 180 degrees. So DE, that is a straight line, the sum of the angles on DE, that is a straight line, equals to 180 degrees, and especially the sum of the angles at point O on the straight line DE must be equal to 180 degrees. So what are the sum of the angles at point O on the straight line DE? It is actually, this angle is 90 degrees, plus this angle that is actually angle EOB. So the sum of those two angles must be equal to 180 degrees according to the rule, according to this rule. So 90 degrees plus angle EOB must be equal to 180 degrees. So here we will subtract 90 degrees from this equality, and we will get that the size of angle EOB equals to 180 degrees minus 90 degrees equals to 90 degrees. So actually angle EOB is a right angle. And if angle EOB is a right angle, then triangle EOB is a right triangle. But before that, here we have, by extending CBDO to point E, we actually created two vertex angles. Actually, angle EBO and angle ABC are vertex angles. Again, angle EBO and angle ABC are vertex angles. So I will draw them again in order to make it more clearly. In order to see it more clearly, I will draw them again. So we have angle EBO So actually, the two angles that I marked in red color are two vertex angles. This is angle ABC, it is a vertex angle, and this angle EOBE is also a vertex angle. So those two angles are vertex angles. Okay? And we have a rule. The rule states that vertex angles are equal to each other. Again, the rule states that vertex angles are equal to each other. That is to say, in our example, those two vertex angles are equal to each other. That is to say, vertex angle ABC is equal to vertex angle EBO. Okay? According to this rule, that vertex angles are equal to each other. But what is the size of angle ABC? The size of angle ABC is theta plus theta is 2 theta. So the size of angle ABC equals to 2 theta, and from this equality we can derive that angle EBO also equal to 2 theta. Okay, angle EBO equals to 2 theta. So we can write here that angle EBO, this angle, equals to 2 theta. Okay? So in the right triangle, triangle EBO, the sum of the angles is 180 degrees. So we will focus on the right triangle, triangle EBO. in triangle EBO, the sum of the angles is equal to 180 degrees. So this angle that is 90 degrees plus this angle that equals to 2 theta plus this angle that is angle OEB must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay? So the sum of the angles in the right triangle EBO equals to 180 degrees. So here we can subtract 90 degrees from this equality, and we will get that 2 theta plus angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. So from this equality we will subtract 2 theta, and we will get that the size of angle OEB is actually 90 degrees minus 2 theta. Okay, the size of angle OEB, the size of this angle is actually 90 degrees minus 2 theta. Okay, so in the right triangle DCE, we will focus on the right triangle DCE. The sum of the angles also equals to 180 degrees. That is to say, the size of angle EDC plus this angle that equals to 90 degrees plus this angle that equals to 90 degrees minus 2 theta. So the sum of those three angles in triangle DCE must be equal to 180 degrees. Okay? The sum of the angles in triangle, the right triangle DCE equals to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees, and we have 180 degrees in the other side of the equality, so 180 degrees will get cancelled. So in the other side of the equality we will have 0, and in this side of the equality we will have angle EDC minus 2 theta equals to 0. So here we will add to this equality 2 theta, and we will get that angle EDC equals to 2 theta. Okay, angle EDC equals to 2 theta. So we will continue to focus on the right triangle DCE. So on the right triangle DCE, we can implement the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the square to the sum of the squares of the perpendiculars, that is to say CD square plus CE square equals to DE square. Okay, so on the right triangle, triangle CDE, according to the Pythagoras theorem, CD square plus CE square equals to DE square. What is the value of CD? CD equals to 2 units. It is given us in the question. So CD square is 2 square, 2 square is 4, plus CE square equals to DE square. What is the value of DE? DE is the diameter of the semicircle, and so it equals to 2r, and r equals to 3, so 2r equals to 6. So DE square is 6 square, and 6 square is 36. So in total we got that 4 plus CE square equals to 36. Here we will subtract 4 from this equality, and we will get that CE square equals to 36 minus 4 is 32. So here we will take a root out of this equality, and we will get that CE equals to the root of 32, and 32 equals to 16 times 2, and the root of 16 is 4. So in total we got that CE equals to 4 times root 2. Okay, again, CE equals to 4 times root 2. We will continue to focus on the right triangle, triangle CDE. So on the right triangle, triangle CDE, we know that tangents 2 theta equals to CE over CD. Okay, tangents 2 theta equals to CE over CD, but we have already found out that CE equals to 4 times root 2, so we can substitute CE by 4 times root 2. And CD equals to 2 units, it is given us in the question. So we have 4 times root 2 over 2, 4 over 2 is 2. So in total we found out that tangents 2 theta equals to 2 times root 2. Okay, tangents 2 theta equals to 2 times root 2, and we know that the radius of the small circle equals to AB times tangents theta. So we need to find the value of tangents theta, not the value of tangents 2 theta. So in order to get the value of tangents theta from tangents 2 theta, we will use a special trigonometric identity that states that the value of tangents 2 theta equals to 2 tangents theta over 1 minus tangents theta, tangent square theta. Okay? So we will use this trigonometric identity in order to find out the value of tangents theta. We have already found out that tangents 2 theta equals to 2 times root 2, so we can substitute tangents 2 theta in the trigonometric identity by 2 times root 2. It will be equal to 2 times tangents theta over 1 minus tangents square theta. Okay, so we will define tangents theta as x, and then we will substitute tangents theta by x. So tangents theta will be defined as x, and then we will substitute tangents theta in this equality by x. We will get that 2 times root 2 equals to 2 tangents theta is 2x over 1 minus tangents square theta is x squared. Okay, so in total we got that 2 times root 2 equals to 2x over 1 minus x squared. Here we will multiply this equality by 1 minus x squared, and we will get that 2 times root 2 times 1 minus x squared equals to 2x. So here we will divide this equality by 2, and we will get that root 2 times root 2 times 1 minus x squared equals to x. 2x over 2 is x. We will open the brackets in this side of the equality, and we will get that root 2 minus root 2 x squared equals to x. Here we will add to this equality root 2 squared, root 2x squared. We will get that root 2 equals to root 2x squared plus x. Here we will add to this, we will subtract from this equality root 2, and we will get that root 2x squared plus x minus root 2 equals to 0. So here we have a quadratic equation. Actually, the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find out the variable x according to a special formula for x. Actually, x equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out. So in our specific quadratic equation, root 2x squared plus x minus root 2 equals to 0, the coefficients of our specific quadratic equation is a equals to root 2, b equals to 1, and c equals to minus root 2. Okay, so we will put the data inside the equation for x in order to find out the value of x that equals to tangents theta. So x will be equal to minus b equals to 1, so minus b is minus 1, plus minus root of b squared is 1 square, 1 square is 1, minus 4 times a is root 2, times c is minus root 2, over 2a, 2a is 2 times root 2. So here we have x equals to minus 1, plus minus. In the brackets we have 1, minus times minus is plus, and root 2 times root 2 is 2, and 2 times 4 is 8. 8 plus 1 is 9. So in total we got in the root only 9 over 2 times root 2. Okay, so we have x equals to minus 1 plus minus the root of 9 is 3 over 2 times root 2. Okay, so we have here two solutions for x. The first solution for x is that x equals to minus 1 minus 3 over 2 times root 2. 1 minus 1 minus 3 is minus 4 over 2 times root 2. And minus 4 over 2 is minus 2 over root 2. Minus 2 over root 2 is less than 0, is a negative number. And actually x is tangent theta, so in the drawing we have the right triangle, triangle ABP. Angle ABP equals to theta. So I will draw it again. A, B, P. This is right angle, this is point P. Angle ABP equals to theta. So actually the sum of the angles in any triangle equals to 180 degrees. So angle APB plus angle theta plus 90 degrees must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that angle APB plus theta equals to 180 degrees minus 90 degrees is 90 degrees. Here we will subtract APB from this equality, and we will get that theta equals to 90 degrees minus angle APB so 90 degrees minus APB is less than 90 degrees. Okay, so from this equality we can derive that angle theta is less than 90 degrees, and if angle theta is less than 90 degrees, then tangent theta is a positive number. Okay, tangent theta is greater than 0, it is a positive number. So tangent theta must be a positive number. But according to our result for x, we got that x that equals to tangent theta it equals to minus 2 over root 2, that is negative number. So here we have a contradiction, because from one side tangent theta must be a positive number. X that equals to tangent theta must be a positive number. But from the other side, according to the result for x, tangent theta will be negative number. Because of that contradiction, we can deduce that this answer is not correct answer. So we will cancel this answer, and the only answer that is left for x, that x equals to minus 1 plus 3 over 2 times root 2. Minus 1 plus 3 is 2, and 2 over 2 times root 2 is 1 over root 2. So x equals to 1 over root 2, and x is tangent theta, so tangent theta equals to 1 over root 2. Okay, we found out that tangent theta equals to 1 over root 2. We'll copy it again. Tangent theta equals to 1 over root 2. And we have already found out that tangent 2 theta equals to 2 times root 2. Okay, again, tangent theta equals to 1 over root 2, and tangent 2 theta equals to 2 times root 2. Again, we want to find out the radius of the small circle. The radius equals to AB times tangent theta. So we have already found out that tangent theta equals to 1 over root 2, and the only thing that is left to find is to find the value of AB. Okay? So in the right triangle, triangle EBO, in the right triangle, triangle EBO, we know that tangent 2 theta equals to OE over OB. OE over OB. Okay, in the right triangle, triangle EBO, tangent 2 theta equals to OE over OB. But what is the value of OE? OE equals to 3 units. So it is 3 over OB. Okay, so we found out that tangent 2 theta equals to 3 over OB, but we have already found out that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. Okay? 2 times root 2 equals to 3 over OB. So here we will multiply this equality by OB, and then we will divide it by 2 times root 2, and we will get that OB equals to 3 over 2 times root 2. Okay, so actually we found out that OB equals to 3 over 2 times root 2. Okay, so we can write here that OB equals to 3 over 2 times root 2. Okay, so in the next step we will join together points P and O by straight line. So actually triangle APO is a right triangle because of the fact that angle OAP is a right angle. So we have the hypotenuse OP. We will extend the hypotenuse OP until it touches the two circles at point M. Point M is the touching point between the two circles, the small circle and the semicircle. and also point M is the point that to which we extended the hypotenuse OP. We extended the hypotenuse OP to point M. Okay? So what is the value of MP? MP is the radius of the small circle because it starts from the center of the circle, that is to say from point P, and ends at point M, that is a point on the small circle itself. Therefore, MP is the radius of the small circle, that is to say it equals to small r. MP equals to small r. And what is the value of MO? O is the center of the semicircle. So MO starts from the center of the semicircle and ends at point M, that is a point on the semicircle itself. Therefore, MO is the radius of the semicircle, that is to say it equals to capital R. So MP equals to small r and MO equals to capital R. And what is the value of OP? OP equals to MO minus MP. Again, OP equals to MO minus MP. OP equals to MO minus MP. Okay? Again, OP, the hypotenuse OP equals to MP equals to MO minus MP, but we have already found out that MO equals to capital R and MP equals to R, so we can substitute MO by capital R and MP by small r. Okay, so OP equals to capital R minus small r. But we know that capital R equals to 3 units, so in total OP equals to 3 minus small r. So we found out that OP equals to 3 minus small r, that is the hypotenuse of the right triangle APB. And we know that AP equals to small r. Okay, so in the right triangle APB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AP square plus AO square equals to PO square. Okay, again, in the right triangle APB, AP square plus AO square equals to PO square. What is the value of AP? AP equals to R, to the radius of the small circle. So AP square is small r square plus AO square equals to PO square. We have already found out that PO equals to 3 minus small r. So PO square will be equal to 3 minus small r square. So r square plus OA square equals to 3 minus small r square. Here we will open the brackets in this side of the equality, and we will get that r square plus AO square equals to 3 minus r square is 9 plus r square minus 6r. Okay, so here we have r square in this side of the equality and we have r square on the other side of the equality, so r square will get cancelled. What we left after we cancelled r square is AO square equals to 9 minus 6r. So here we will take a root out of this equality and we will get that AO equals to the root of 9 minus 6R. AO equals to the root of 9 minus 6R. And we have already found out that OB equals to 3 over 2 times root 2. OB equals to 3 over 2 times root 2. Okay? And what is the value of AB? The value of AB is actually OA minus OB. AB equals to OA, OAO it is the same, minus OB. Again, AB equals to OA minus BO, or OB or BO is the same. AB equals to OA minus BO. Again, AB equals to OA minus OB. And we have already found out the value of OA and OB. So we will substitute OA by its value and we will substitute OB by the value that we found for OB. So AB will be equal to OA. We found out that OA equals to the root of 9 minus 6R minus OB. OB is 3 over 2 times root 2. So that is the value of AB. And we have already found out that tangent theta equals to 1 over root 2. Okay? And the radius of the small circle equals to AB times tangent theta. So the only thing that is left to do is to substitute AB by the value that we found for AB and to substitute A tangent theta in this equality by 1 over root 2. And in this way we'll find the radius of the small circle. So the radius of the small circle will be equal to AB. AB equals to root of 9 minus 6R minus 3 over 2 times root 2 times tangent theta is 1 over root 2. So here we will multiply this equality by root 2 and we will get that root 2 times R equals to root of 9 minus 6R minus 3 over 2 times root 2. Okay? So we found out that root 2 times R equals to root of 9 minus 6R minus 3 over 2 times root 2. Here we will add to this equality 3 over 2 times root 2 and we will get that 3 over 2 times root 2 plus root 2R equals to the root of 9 minus 6R. So here we will divide root 2R by 2 times root 2 and then we will multiply it by 2 times root 2 in order to have a common factor with this expression. So root 2 times R times 2 times root 2 over 2 times root 2 plus 3 equals to the root of 9 minus 6R. Here root 2 times root 2 is 2 and 2 times 2 is 4, so in total we will get that is in the numerator 4R plus 3 over 2 times root 2 equals to the root of 9 minus 6R. So here we will square this equality and we will get that 4R plus 3 squared and 2 times root 2 square is 8, equals to, we have here root, and we square the root. When we square the root, we cancel it, because the square cancels the root. So when we square this root, the root will get cancelled, and what is left is 9 minus 6r. So in total, we found that 4r plus 3 square over 8 equals to 9 minus 6r. Here we will multiply this equality by 8. So we will get that 4r plus 3 square equals to 8 times 9 is 72, and 8 times minus 6r is minus 48r. So here we will open the brackets, this side of the equality, so 4r plus 3 square is 16r square plus 9 plus 4r times 3 is 12r, and 12r times 2 is 24r, equals to 72 minus 48r. Here we will add to this equality 48r, and we will get that 16r square plus 9, 24r plus 48r is 72r, equals to 72. Here we will subtract 72 from this equality, and we will get that 16r square plus 72r minus 63 equals to 0. So we have here a quadratic equation, and the coefficients of this quadratic equation is a equals to 16, b equals to 72, and c equals to minus 63. Okay, those are the coefficients of this quadratic equation, and the solution for a quadratic equation for x is x equals to minus b plus minus root of b square minus 4 times a times c over 2a, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out. But in our specific quadratic equation, the variable that we want to find out is r, so x equals to r. So we will put the data inside the formula for x, and we will get that x equals to r, so r equals to minus b is 72, so minus b is minus 72, plus minus root of b square, b is 72, so 72 square is 5184, minus 4 times 16 is minus 64, minus 64 times minus 63 is plus 4032, all divided by 2a, a is 16, so 2a is 32. We will get that r equals to minus 72 plus minus, and the root 5184 plus 4032 equals to 9216 over 2a is 32. So we got that r equals to minus 72 plus minus the root of 9216 is 96 over 32. So we have here two solutions to this quadratic equation, two solutions for r. The first solution is that r equals to minus 72 minus 96 over 32. Minus 72 minus 96 is minus 168 over 38 is minus 5.25. So we found out that r equals to negative number, but it is impossible that r is negative. R must be a positive number. R must be a positive number. The radius of the circle must be a positive number. Okay, so r must be a positive number, therefore this solution is incorrect solution, and we left only with the solution, the second solution, that r equals to minus 72 plus 96 over 32. So minus 72 plus 96 is 24, and 24 over 32 is 3 over 4 units, or 0.75 units. So r equals to 3 over 4 units, or 0.75 units. Okay, so the radius of the small circle, this small circle, equals to 3 over 4 units, or 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle. This small circle is inside a semicircle, and we know that in any semicircle, actually this is the radius, and dO is also the radius of the semicircle. So we can write here that capital R equals to 3. This is the radius of the quarter circle, and we also know that angle BCD equals to 90 degrees, and we know that CD equals to 2 units and R equals to 3 units. The radius of the quarter circle equals to 3 units, and we want to find out the radius of the small circle. Okay, so first of all we defined the center of the semicircle as point P, and then we join together points A and P by a straight line. AP is the radius of the small circle because of the fact that it starts from the center of the small circle and ends at point A, that is a point on the small circle itself. Therefore AP is the radius of the small circle, and so also PX is the radius of the small circle. We joined also points P and B by a straight line, and then we defined angle ABP as theta, and actually BA is tangent to the circle, to the small circle at point A, and there we have also, here we have radius, and we have a rule that the radius and the tangent are perpendicular to each other. So angle PAB equals to 90 degrees. Therefore, triangle PAB is a right triangle, and we can say that tangent theta equals to AP over AB. AP is R, so tangent theta equals to R over AB. And so actually R, the radius of the small circle, equals to AB times tangent theta. So in order to find out the radius of the small circle, we have to find out the value of AB and the value of tangent theta. Okay? Then, so R equals to AB tangent theta. Then we proved that the green triangle is congruent to the white triangle because we have side AP equals to side PX. Both of those two sides are the radiuses of the small circle. PB equals to PB, it is a common side, it belongs to both triangles. And AB equals to BX. Actually AB is tangent to the small circle, and BX is also tangent to the same circle, and both those two tangents exiting from the external point, common external point, that is to say from point B. And we have two tangents theorem that states that the lengths of two tangents from a common external point to a circle are equal. So the length of those two tangents AB and BX that exiting from a common external point, that is to say from point B, are equal to each other, so AB equals to XB. Therefore, we actually proved that all the sides of the green triangle are congruent to all the sides of the white triangle. Therefore, the green triangle is congruent to the white triangle, and from the fact that those two triangles congruent to each other, we can derive that angle ABP equals to angle PBX. Those two angles are equal to theta, so because angle ABP equals to theta, so angle PBX that equals to angle ABP must be also equal to theta. Okay, and we can derive this from according to the rule that corresponding angles in congruent triangles are equal to each other. So we have two triangles that are congruent to each other, therefore the corresponding angles that are angles ABP and angle PBX are also equal to each other. Okay, and then we extended CB and the radius DO until they intersect each other at point E. In this way we created two vertex angles, and we have a rule that vertex angles are equal to each other. Okay, therefore vertex angles equals to vertex angle ABC equals to 2 theta plus theta is 2 theta, so the vertex angles EBO that equals to ABC must be also equal to 2 theta. Okay, then we have the peripheral angle DCE that equals to 90 degrees, and we have a rule that states that any peripheral angle that equals to 90 degrees rests on the diameter of a circle. So peripheral angle DCE that rests on the diameter, the peripheral angle DCE that equals to 90 degrees must rest on the diameter of the quarter circle, that is to say, DE is the diameter. Because of the fact that the peripheral angle DCE rests on DE, DE must be the diameter of the quarter circle. Okay, so DE is the diameter of the quarter circle and also of the semicircle. We completed the quarter circle to a semicircle, so DE is also the diameter of the semicircle. And we know that the diameter of any circle equals to 2 times the radius. And we have already found out that DO equals to the radius. So in order that DE will be equal to 2R, EO must be also equal to R, because only then DO will be equal to R plus R, or OE equals to DE, that is 2R, minus DO, that is R. So 2R minus R is the size of OE, so OE also equals to R, that is 3 units. Okay? And then we have DE, that is the diameter of the semicircle, and therefore DE is a straight line. And we have a rule that the sum of the angles on a straight line equals to 180 degrees, and especially at point O on the straight line DE, the sum of the angles must be equal to 90 degrees. So this angle that is 90 degrees plus angle EOB must be equal 180 degrees. Okay, 90 degrees plus angle EOB must be equal to 180 degrees. We subtract that 90 degrees from this equality, and we will get that angle EOB equals to 90 degrees. So this angle is the right angle. So if this angle is the right angle, then triangle EOB is the right triangle. And we actually found out that in triangle EBO, the sum of the angles is 180 degrees, and this angle is 2 theta, this angle is 90 degrees, so this angle must be equal to 90 degrees minus 2 theta, and also in the right triangle DCE, we know that this angle equals to 90 degrees minus 2 theta, and this angle is 90 degrees, so this angle must be equal to 2 theta in order to complete the sum of the angles in the right triangle DCE to 180 degrees. So this angle equals to 2 theta, and then so in the right triangle DCE, according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of the perpendiculars, that is to say DC square plus CE square equals to DE square. Okay, CD square plus CE square equals to DE square. We know that CD equals to 2, so this CD square equals to 2 square, it is 4, plus CE square equals to DE. DE is the diameter of the semicircle, that is to say it equals to 2R, R equals to 3, so 2R equals to 6. So DE square is 6 square, 6 square is 36. So we got that 4 plus CE equals to 30, plus CE square equals to 36. We subtract that 4 from this equality, and we got that CE square equals to 42, and actually we found that CE equals to 4 times root 2. And then in the same right triangle CDE, times 2 theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2 and CD equals to 2 units. It is given us in the question. So in total we found out that times 2 theta equals to 2 times root 2. Okay, we found out that times 2 theta equals to 2 times root 2, and the radius of the small circle equals to AB times 2 theta. So the only thing that is left to find is the value of AB. In order to find out the value of tangents, we have only the value of tangents 2 theta, and in order to find out the value of tangents theta, we have the special trigonometric identity that states that tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Okay? But we have already found out that tangents 2 theta equals to 2 times 2 theta, so we can substitute tangents 2 theta in the trigonometric identity by 2 times root 2. So we substituted it, and we got this equality, and then we defined tangents theta as x. So we substituted tangents theta by x, and we got the quadratic equation that root 2x squared plus x minus root 2 equals to 0. We solved this quadratic equation, and we found out that the value of x, that is actually tangents theta, is 1 over root 2. So tangents theta equals to 1 over root 2, and tangents 2 theta equals to 2 times root 2. So we know that the radius of the small circle equals to AB tangents theta. We found out the value of tangents theta, it equals to 1 over root 2, and the only thing that is left to find is to find the value of AB. So in triangle EBO, we know that tangents 2 theta equals to OE over BO. But we know that OE equals to 3 units. Okay, so it is, and we know that tangents 2 theta equals to 2 times root 2. So we substituted tangents 2 theta by 2 times root 2, and we found out that OB equals to 3 over 2 times root 2. Okay, OB equals to 3 over 2 times root 2. And then we join together points P and O by a straight line. And actually triangle APO is a right triangle because of the fact that angle PAO equals to 90 degrees. So in the right triangle APO, we extended the hypotenuse PO until it touches the two circles at point M. MP is the radius of the small circle and MO is the radius of the big circle. So PO equals to MO minus MP, that is to say it equals to capital R minus small r. Or PO equals to capital R is 3, so PO or OP equals to 3 minus R. So in the right triangle APO, we know that the square of the hypotenuse equals to sum of the square of the perpendiculars, that is to say AP square plus AO square equals to PO square. AP square plus AO square equals to PO square. AP equals to the radius of the small circle plus AO square equals to PO square. PO equals to 3 minus R, so PO square equals to 3 minus R square. We open this brackets and we found out that AO equals to root 9 minus 6R, and we already found out that OB equals to 3 over 2 times root 2. And what is the value of AB? AB equals to AO minus BO. And so AB equals to AO minus BO, and we already found out the value of AO and the value of AB. So we substituted AO by its value and we substituted BO by its value. So that is the value of AB, and we have already found out that tangent theta equals to 1 over root 2. And we know that the radius of the small circle equals to AB times tangent theta. We have here the value of AB and the value of tangent theta, so we multiply one by each other. We got this equality, and from this equality we got a quadratic equation with the variable r. We solved this quadratic equation and we found out that the radius of the small circle equals to 3 over 4 units or 0.75 units. Okay, so the radius of this small circle equals to 3 over 4 units or 0.75 units. Okay, thank you very much.